Let's find the limit as x approaches infinity of 8 to the x, ln of x, all over 7 to the x plus x. I did this problem using L'Hopital's rule, but it was a little tedious, and I think that it would be better to find the limit without necessarily using L'Hopital's rule, even though that's the way Alex had given us the problem. But in order to do that, we do need to know about the dominance of certain types of functions. In particular, if you take a look at a function b to the x, where b is some number greater than 1, it turns out that's going to be greater than x to the n. So it's greater than any power of x. Any power of x is also going to be bigger than the natural log of x. In other words, the way the functions grow as x is getting larger and larger and larger. And so if we take a look at that observation, that's going to be very helpful. So I'm going to first start off by finding the limit by dividing top and bottom by 7 to the x. So I'll have the limit as x approaches infinity of 8 to the x, ln of x, all divided by 7 to the x, all over 7 to the x plus x divided by 7 to the x. When I simplify, then I'll get the following. The limit as x approaches infinity. For the main numerator, I'm going to rewrite that 8 to the x over 7 to the x as 8 over 7 to the x times ln of x. And in the main denominator, I'm going to divide each term by 7 to the x. So 7 to the x over 7 to the x is going to give me 1 plus x over 7 to the x. Now, I maintain that if b is bigger than 1, then 7 to the x is going to be greater than x. And we can see that for small values of x. For example, when x is 1, we get 7 is bigger than 1. When x is 2, we get 7 squared is bigger than 2, and so forth and so on. So if that's the case, that this number here, 7 to the x, is bigger, that means as x increases without bound, the 7 to the x is going to grow faster than the x. In other words, you can think of this almost like a constant over a power of x, which is going to go to 0. So as x increases without bound, the x over 7 to the x is going to go to 0. And the same would be true if we had the natural log of x over 7 to the x. That also would go to 0 because the natural log of x is slower. Since 7 to the x is going to grow faster, then the ln of x is going to be slower. So this is going to go to 0 because the denominator is getting larger faster than the numerator. And then we have in the numerator, since 8 over 7 is bigger than 1, we know that this expression is going to increase without bound, as well as the natural log of x. It's going to increase without bound. So we get that our answer is equal to infinity.